We left off with A. So we were talking about domain. Remember, domain are the x values. Okay. The very last thing we did with it is we graphed it, and we looked at the graph going from left to right. And that's what we finished up with it right there at the end. And that is the graph starts at -3 and goes right to infinity. Okay. We also figured that out, though, because remember, anything under a square root must be positive. And so that's my clue in the equation that, oh, hey, x plus 3 has to be positive, so x has to be greater than or equal to -3. The other thing that we didn't have the example of, so square roots have to be positive, denominators cannot be 0 is the other piece. Okay, so as we move into B, let's talk about the domain in B. Okay. Before we look at the graph, I want to talk about the equation. What are some pieces you see in the equation that we should talk about here?
I don't know.
Well, square root x, you can just say x is greater than or equal to 0.
Okay. So there's just like part A, there's a square root, yes? Whatever's under that square root has to be positive or greater than or equal to 0. So what's under this square root? It's just x. So part of what's going to happen with this graph is everything has to be greater than or equal to 0. With that's saying that everything has to be to the right of 0, yes? Okay, so that's part of what's going to figure into our domain. Now, I just mentioned this. We didn't have an example with it yesterday, but what do we know about denominators? Denominators can never equal 0. So what we want to figure out is what values will make this denominator equal 0, because then those values are excluded. And so to figure out what will make the denominator equal to 0, we're going to set the denominator equal to 0.
You can do one of those ones where it like goes right by 0, like it curves.
Yes. Well, not at 0, it's not going to.
Okay, but hear me out though. Can't we just like solve it right? Because like x squared, like 5 squared is 25. 25 x squared.
Right. In other words, you can pretty much eyeball it, yes. I'm not going to argue that. Now, there's actually 2 answers here, though.
Plus or minus.
Plus minus.
Yeah. So officially, if we solve this, x squared equals 25. Remember, when you take the square root, you have to accommodate for the positive and the negative. So plus or minus 5. Now, I just wrote x equals plus or minus 5, but really what it is that x...
Or not equal.
No, it can't equal positive and negative 5.
Why?
Because it can't be set.
Because those are the 2 values that would make your denominator equal to 0. Okay, by setting the denominator equal to 0, we're finding the values that cannot be part of my domain because they would make the denominator equal to 0. But if we use 5 or negative 5, they would make this fraction not exist. Okay, so what we're going to see, and we'll talk about this later in 1.2, is we're going to see some vertical asymptotes at 5 and negative 5. Okay. Now, again, we haven't looked at the graph yet, have we? And I'm going to here in a moment, but just think number line with me. Important points we just talked about are 0, negative 5, and 5, yes? I'm just trying to get you to think. This is just kind of like what my brain is thinking right now. So if we're looking at this, we know, first of all, that x cannot equal 5 and negative 5, yes?
Yeah.
So that's the idea that if x cannot equal 5 and negative 5, I'm thinking like open circles for the moment. Okay, just trying to visualize.
Okay.
If x is greater than or equal to 0, what's that say?
It's to the right of 0.
It's to the right of 0. Now, what's it going to do at 5?
Stop.
It's going to skip over 5.
That's right.
And then it's going to continue. Okay?
That's what my graph is.
Now, is 0 included?
cheated one up there.
Do I include 0?
Yeah.
Yeah, because you can have a 0 on top. It can be the square root of 0. Now, if we're thinking circles, it's a closed circle, but what are we really going to need to think here? Parentheses and brackets, yes?
Oh, yeah.
So at 0, there's going to be a bracket. Now, what's going to happen at 5?
A parenthesis.
It's gonna parenthesize.
Yeah.
And then also a parenthesis. Yeah.
Okay. Are you seeing where I haven't written my interval notation yet, but this is where I'm trying to get your brains to go there. Now, does it matter this -5 over here? Does it matter that that's not included?
Irrelevant.
It ends up being irrelevant because the whole left side of that graph is not included. Okay. So,
I'm kidding, buddy.
with us in mind,
I'll go to the DD party.
interval notation. Where's the domain going to start, we think?
0.
At 0 with a bracket, comma. Now, my 0 travels to where? Or my graph travels to? 5. But it's not going to touch 5, so we're going to use a parenthesis.
And then U.
And then we're going to use the U for union. And then we're going to pick up on the other side of 5. So parenthesis 5 to
Infinitely.
infinity, and infinity is always used parenthesis. Now, with my guidance, you just did that without ever looking at the equation. Unless you're honest and you looked at the equation.
No, it was.
Yeah.
Calculator makes it easy.
It was Logan that looked at the equation. Sorry.
Now,
Sorry.
here's what I'm going to do real quick. Is I'm going to put this in on the graph because here's what I want you to get to being able to do. Is I want you to get to where you can use the graph and the equation together. Okay? So, feel free to graph it on yours as well.
I just plugged it in. Right, starting it. Just now?
Mm-hmm.
Yeah.
What?
Graph. Honestly, we'll hit him with some
Okay,
music today.
so
What the?
square root of x over x squared minus 25.
What in the world?
I'm going to do a zoom 6.
Never seen that before.
Liar.
Now, it's kind of hard to tell here. I mean, it's one of those things that you zoom in more, you might, or you kind of change your window, you might be able to tell a little bit more. But so here's a good trick too. You know my trace button.
Yes.
If I hit trace, notice it always pops on the graph when y equals 0. So it pops on the graph at 0. If I arrow to the left, notice
Nothing.
my y value just disappeared, yes?
Yes.
That tells me my graph does not exist over here. So thus, there's no x values, they're not in the domain. Okay? Now, if I go back and I start going to the right, okay, so now I've got, with my x values, I have y values, so these, we can see the graph, it's part of the domain. And as you approach 5, you can physically see the little break there, can't you? Okay? It's a vertical asymptote. The graph doesn't draw vertical asymptotes on. And the graph actually extends more than that. It's just kind of graphing calculator failure. But if you kind of watch your x values, 4.6, 4.8. Okay, I didn't expect to actually show 5. Notice at 5, what does it say my y value is? It says my y value does not exist. Thus, why did we use parentheses? There's a break in the graph there. It doesn't exist. If you then continue one more, now at 5.1, I'm back having y values again. And it would keep going on to infinity. Okay? So if I'm looking at this, here's my thought. I like to know, I can see by looking at my equation, 0 is going to be important because there's an x under the square root. 5 and -5 are going to be important because of x squared minus 25 in my denominator. Now, knowing those numbers, okay, as I start on the left side of my graph, the first place my graph exists, 0. Then there's a break at 5, so 0 to 5. picks up after 5, 5 to infinity. Am I making sense, like how the graph goes with what we just figured out? Because in all honesty, if you glance at the equation, you could go straight off the graph. But you do need to have some knowledge of what's going on in that equation as well. Okay?
Sure.
Okay, questions I can answer there.
Can we go to the next one?
I'm ready.
No, we can
I
have
want to make sure you guys are ready.
born and raised.
That is your saying today, isn't it? Okay, we have 2 more domains on the back before we talk a little bit about range. Okay, find the domain of each of these functions.
Well,
So this first one, a of s, equals the square root of 3 over 4 s squared. Think with me before we look at the graph. Square roots and denominators. Okay, do we have any square roots?
mm-hmm.
We do, but what's under it?
Fraction.
Now what's under the square root?
Oh, 3.
3. Are there any variables under the square root?
Negatory.
No. So is that going to matter? No. Do we have any denominators?
Mm-hmm.
Yeah.
We have a denominator of
4.
4,
4.
but any variables in the denominator?
No.
No. So the pieces that we talked about are, pieces in the square root, pieces in the denominator. Those aren't going to matter. We just have that square root of 3 over 4, which is just a coefficient, and then s squared.
Isn't that technically times like s squared over 1?
You could think of it as s squared over 1, but we don't need to put it in a fraction unnecessarily. The key is there's no variables under square roots. There's no variables in the denominator. What's this graph look like?
I don't want to answer.
Maybe parabola
Why might it be a parabola?
squared.
It's in terms of a and s. We'll talk about y here in a little bit. Okay. But, folks, s squared, x squared, that's a
Parabola.
parabola, yes?
Parabola.
Now, just looking at that and realizing this is a parabola, that square root of 3 over 4 is just your vertical compression. Okay, that's all that is.
Facts.
Actually, vertical stretch maybe.
Back it up.
But it's a parabola. What do you know in general about the domain of parabolas?
They are
They're infinity.
infinite. Yeah.
Okay, so parabolas go infinitely up, and as they're going infinitely up, they are getting
Wider.
So that's our
infinitely
answer.
wider. Now, so we're going to think about this, yes, as all reals, or in other words, the negative infinity to infinity. And in terms of this being a general equation, based on looking at the equation, I totally agree with this, okay? If, I'm not even going to graph this one on the calculator, but if I graph it, it is indeed a parabola, okay? And parabolas are going to have that domain of all real numbers. Now, there is one catch to think about. This isn't in our traditional x's and y's. This is, the function is written as a of s instead of f of x. Thoughts about what that a could stand for in terms of math?
Area.
Okay. Does a often stand for area?
Yes.
Okay. Now, s, when you're finding area, what does s stand for?
Side.
Side.
Side. Yeah. Area
Okay.
of the side.
So
Oh.
this
no.
is
What?
this formula is an area formula based on the side of an equilateral triangle with side s. Okay.
I don't think that.
Now, all of this to say, looking at the equation, yes, my domain is all real numbers. Realizing that s stands for the side of a triangle. How do we have to refine that answer? Can my domain still be all real numbers? if we're talking about the side of a triangle.
Well, you just said it was, so.
I said based on looking at the equation, not considering what the equation represents.
How do we
Based on the equation, just hang with me here.
No, where do we get triangle from it though? It could be
Okay.
any side. Like, it could be any.
Okay, hold on, hang with me here. Okay. Based on just looking at the general equation, it's a parabola, domain, all real numbers. Okay, now, what I'm trying to make the point to you is that this is a specific formula. I know, unbeknownst to you, this is not a formula you guys recognize, but the fact A stands for area, S is side. This is an area formula based on the side. If we're talking area and side, I'm going to tell you it's a triangle because I know that. But what do you know about the side of any object? Can it be all real numbers?
I'm gonna go with no.
Why not? Think about this. You guys know this answer. Why could a side of a triangle, a side of any object,
Because
not
it's
have a
gonna end
domain
at
of
some-
all real
It's
numbers?
gonna end at some point.
Can't be
No.
negative.
It's gonna stop. It's a line segment. It's gonna stop.
Right, but
It can't
I-
be negative.
can a side be negative?
No.
Right? Can the side of a triangle have a negative length?
No. It
No.
can't. It's gotta
Okay.
be a positive.
Right. So what I'm trying to get you guys to realize that, well, yes, a parabola. I'm not arguing that fact. A parabola has a domain of all real numbers. You guys are right on that. The point I'm trying to make is in math, you sometimes have to realize that, oh, we're talking about a side of a triangle. We're only talking about the positive values. We're not going to be talking about the negative values. Okay? So because this formula models the area of a triangle with side S, then we're going to say it's only numbers bigger than 0. Okay?
And the formula later on that has this. I'm guessing. That's where we get the triangle from.
Like, I just don't get how like we figure out triangle and it's not like a square or a rectangle or a.
Some teachers are going to argue this is a formula you should know. Okay? Regardless, it doesn't matter what shape it is. The side of any shape is always going to be positive. I'm telling you it's the area of a triangle, area of equilateral triangle formula. Because I know that. I'm not expecting you to know that. What I'm trying to get is I'm trying to get you guys to read the clues of A stands for area. S stands for side. This might be area formula based on a side. That's what I'm trying to get you guys to read out of this. Am I expecting you to say, oh, yep, that's area of an equilateral triangle, Mrs. Sargent? No, I'm not expecting that. Does that make sense?
Mm-hmm.
This formula represents, area of,
So if a question comes up,
You have a question? What?
if there's a question on like homework or a test that resembles this, but we don't know what, should we just say polygon instead of triangle or like a shape or something?
you could just say area.
I think you're thinking of too much.
I kind of agree. But you could just say this is an area formula. Area is area of a physical object. A physical object will not have a negative length. Okay?
How did you do that?
Second format.
Okay, so this formula represents area of an equilateral triangle with side S, then S is greater than 0. So for domain, I'm using 0 to infinity. Infinity always use parentheses. Do we want to include 0 or exclude 0?
Exclude. Get that man's out of here.
It could be 0 though.
Can you have a side length 0 though?
Yeah, but then it wouldn't be a side because it's not existent.
So side length would have to be positive.
Bada boom. Hey, found it. Boom.
This is what I'm trying to get you guys to realize. This formula represents area. Okay? Area means side length is going to have to be positive. Okay?
Boom.
There's a lot of twists and turns to domain is one thing you're going to discover real quick here. So I'm trying to show some options
Which
here.
one do you see that for?
What are you guys figuring out on the calculator?
Look, it's got a picture on it.
Okay. Why did I ask? D,
Format. Second.
gentlemen, D. Let's go.
I'm ready.
F of x equals the square root of x squared plus 5 all over x. Okay? Now, what kind of pieces of information do we need to think about here?
The x squared on top and the square root.
Okay, there's a square root on top, yes? Okay, so let's talk about the square root. Whatever's under a square root has to be what? Greater than or equal to 0. Because whatever value is under a square root must be positive. Okay? So what happens when we start solving this?
You're not gonna get a perfect square.
Okay? You're not going to get a perfect square. We can work with that issue because we could use square roots in our domain if necessary. What's the real catch, though? What does he have to take the square root of here?
Oh, -5.
A negative 5.
So
Can we take the square root of a negative 5?
No, because imaginary numbers don't exist.
Well, here's the deal. We're talking about a physical graph.
Okay, so then no.
We're not talking about imaginary numbers.
Thank goodness. So no.
Now,
Therefore, doesn't exist.
here's what I'm going to point out here, guys. We always check what's under a square root. That's just automatic rule of thumb. You check what's under a square root. But x squared plus 5. What happens when you put, negatives are usually the issue, right? What happens when you put a negative into x squared? When you put a negative in and you square it, it's going to become
Positive?
positive. And then you have a positive number and you add 5 to it. Do I have to be concerned about this being smaller than 0, being a negative? No. X squared is always going to be positive, no matter what I put in it. And then when I add 5, that's just going to become even more positive. So, with that in mind, basically what we're saying is this is going to end up not mattering. Okay, or in other words, I'm going to say, okay, and I'm going to say because, how do I want to say this? X squared plus 25 is guaranteed positive. I'll say guaranteed positive already. Okay, so basically, we check the square root. If you can solve it and get a value, then yeah, we have an issue. This one, we can get a value, so we didn't have the issue. Okay, square roots. What's the other piece of information we need to check here? Square roots and denominators. Do we have a denominator? Yeah, we have a denominator, and what's in that denominator? We have a variable. What do we know about a denominator? A denominator cannot equal
0.
0.
0.
So if you set your denominator equal to 0, well, that's finding a value that can't exist. So this one is an issue. Okay, x cannot equal 0. That's a problem. Okay, guys, we checked square roots. That one became non-existent issue here. We had a denominator, so x can't equal 0. Based on this information, I haven't looked at the graph yet. What's my domain going to be? If my domain is everything but 0.
Is it just going to be like the other one? With the
It's everything but 0. So what can be included?
negative infinity and infinity, but not 0. Out of what I can take.
Yeah. It just doesn't include 0, does it?
That's right.
So we are going to have to write two separate pieces.
We're going to use union.
I did hear parentheses, and yes, we are going to use a union.
Union.
So negative infinity up to 0, parenthesis, union, 0 to infinity. Now, does this jive with the calculator?
Like calculator real quick.
Okay. Why was my calculator date set to February 8th, 2015? This calculator probably didn't exist in 2015. It's brand
I don't
new.
understand why the calculator dates never make sense to me.
How'd you do that?
In Node.
Okay, gosh darn it, I'm in the wrong place.
I still can't find the format.
Gentlemen, let's graph, please.
I'm there. I got January 20th.
Okay. You end up with a graph that is 2 pieces. Now, if I were doing this without looking at the equation, here, like if we did this algebra 2 style, where's my graph start? It starts over on the left. I'm tracing my graph. What happens here?
It stops at 0. It gets an asymptote.
Okay. It starts going down, but as it's going down, and you can trace this and figure out, notice it doesn't exist at 0, but it ends up just heading down, which is an asymptote, which means my graph is going to get closer and closer and closer to that 0 value, but
Never touch.
never touch it. So then if you arrow right, notice my graph hops over it, and it continues off to infinity. So thus, we have negative infinity up to 0. We have a gap at 0 because of the asymptote, and then we have 0 to positive infinity. Okay? My recommendation as we talk about domain. The graph is always our backup. The graph is an excellent way to, you can start by looking at the graph, okay? I know we're harassing Jans here because he was looking at the graph to begin with. You can start by looking at the graph. I'm not against that, okay? I'm not against that as you get moved to do this on your own. But here's what I'm going to say, is you need to be able to tell me, don't tell me, for instance, let me get off to the left here. Don't tell me my domain is negative infinity to negative 0.15. Okay, because that tells me you're relying solely on the graph and not understanding there's an asymptote there. And it's going to go past that x value. We just, the graph only shows so much there. And that's where, x in the denominator. X can't equal 0. That's that vertical asymptote. Okay? So, use both aspects. Use the algebra, the square roots, the denominators. Use the graph. Make them work together for you. Okay?
On the square roots, I get like square root of 25 is plus or minus 5, but like in this equation, you would take the square root of negative 5, so how's that? Like, why is that okay then?
Well, as in, we can't take the square root of negative 5, and that was kind of my, wait, I can't take the square root of negative 5. What's going on here? Did I make a mistake? What happened? And so when I backtrack and look at this right here, I start thinking, x squared. We know x squared has to be positive because when you take any negative and square it, it will become positive. And then on top of that, when I add 5, it's going to become more positive. So it's not, I guess it's not that this piece is okay. It's just that, that ended up being kind of irrelevant, so to speak. Because x squared plus 5 will never, or x squared plus 5 will never be negative. Okay? It's just recognizing that x squared is positive. I add 5, it's more positive. Okay? If this was x squared minus 5, it'd be a different story. Because there are values in there that would make that square root negative. Okay? Okay. I have 2 range problems to talk about. Okay? Range, there's a slight part of it that I teach similar to domain, but I'll be honest, range, I rely more on the graph. I rely on us, where does my graph start, where does it break, where does it end type thing. Okay? So let's talk about range here. Now, officially this says same rules apply for range as do domain, although if we want to be able to look at the equation, you have to solve for x first. Okay? So that's one piece, is that we will solve for x first if we're looking at the equation, but most importantly, this is what I'm going to stress. Domain, we read the graph from
Left to right.
left to right. Range, we're going to read the graph from
Top to bottom.
bottom to top. It sounds weird to say, but
Yeah, no.
negative to positive, right?
Bottom to top.
It makes sense. It just, trust me, I want to say top to bottom too. Okay, so if we think about this equation here, f of x equals 2 over x. Well, of course, you guys know this is really y equals 2 over x, yes? F of x, another way to say y, we've got that as pre-calc kids. Now, officially, it says solve for x. If we solve this for x, well, that means I want to make it x equals. How do I get divided by x out of the denominator?
Multiply.
Multiply by x.
That's right.
If I multiply one side by x,
Yeah, multiply the other.
okay, we're going to multiply the other side by x. X times y is
XY.
xy. On the right, 2 over x times x.
2.
Yeah, because officially what?
X over 1. X is canceled.
X is cancel. You have 2.
And then divide by y.
Okay.
Which the
Trying to solve for x. So we try and solve for x.
I got it.
We're going to divide by y. We end up with the equation x equals 2 over y. Now, that one's an easy one in that could you very easily solve that one?
Yeah.
Okay, and that's why I'm willing to do it on this one. They're not as always easy to solve for x. And that's where we'll talk about reading the graph more. But, okay, go back to this one. When it was domain and x's, there were 2 issues. X under the square root can't be negative, and x in the denominator can't equal 0. Talk about y's to me. What do we have happening with y's here? There's no square root, but there is a y where? In the denominator. This is my clue then that y is not going to be able to equal 0. Because denominators can never equal 0. It doesn't matter what variables we're talking about. Okay? So right now, if I had to guess what my range is going to be, it's going to be everything but 0.
Like D.
Okay? Now, my suggestion is also look at the graph. Okay? On range, my go-to method is going to be look at the graph.
Boom. You looking.
So the original graph, which was 2 over x, it does look a lot of like the last graph we just looked at, doesn't it?
It do be. It should be do that.
Now, tell me, okay, I need your range brain. Range, where do we start reading?
Bottom to top.
Now, bottom to top, we're talking y's. So, as we start at the bottom here, I'm tracing my graph, I'm thinking y values here. So, my graph is going to go infinitely where? Infinitely down, yes. And then we're going to trace these y values. As I'm proceeding up my graph, what's happening? It's going up, we're including all these y values. And then at some point we start to run off to the left, yes? But as it's going off to the left, it's still going
Down.
up.
Or up, sorry.
It's still going up, it's just going off to the left. What's happening on the x-axis? What is there? There's a horizontal asymptote, right? We just said that y can't equal 0. Do you physically see in your graph how it appears there is a horizontal asymptote? I'm not saying you physically see the asymptote,
No.
but do you see how the graph is shooting off to each side? And that's indicating there's an asymptote. Okay? So right there, that's how I can tell, okay, negative infinity, this 0 doesn't exist. There's an asymptote here, I'm not going to touch 0. And then, what happens? We go infinitely off to the left. We're never ever going to touch 0. But then what happens? My graph picks up on the right, but this time when it picks up on the right, it picks up above 0, above the y-axis. And then what happens as it picks up above? It goes infinitely up. So how am I going to write?
We're gonna
The
unionize.
same thing we just proved.
Yeah, basically 0 doesn't exist. You can have everything on either side. So negative infinity to 0. We don't touch 0 because it's a horizontal asymptote. Union 0 to infinity.
Boom.
Okay, one more. Now, as we look at this last one, f of x equals x squared over x squared minus 1. My first suggestion earlier, or my first saying was, okay, let's try solving for x. When I tried solving for x, that was easy to solve for x. How do you feel about solving this one for x? It's not going to be easy at all, is it?
Not necessary.
Okay. When I see an equation like this, I'm like, oh, that's going to be kind of nasty to solve for x. We're just going to go straight to the graph.
Oh,
We're going to do exactly what Jans wants to do.
I know. That pays off all this hard work.
Okay.
Just guessing ahead. I like to think of mom. She's the one who enrolled me in school.
Okay, so let's graph it. Let's see what crazy stuff is happening.
Boom! Graphed it.
What the heck?
That's like weird.
What is it?
I'm hearing some reactions to this graph.
It looks pretty normal, you know, just kind of like normal. It's a graph.
Okay, so you see the graph on your paper, or on your calculator, right? I'm going to do a quick sketch of it here.
You know what's always hilarious to me? Like the vertical lines get drawn really slow, and then when it shoots up, it goes like really quick. You know what I mean, Becky? Yeah. No, you don't. Like you put it on top of that. Like this one.
Okay, now, I just kind of drew a basic graph here on the screen that I can use to, you have it on your calculator. If I need something I can touch and draw on better. Okay. We are talking range, yes?
Bottom to
So,
Range,
let's get it.
bottom to top. Think with me. How low does my graph go?
negative infinity.
Can we agree it's going down to negative infinity? Yes?
How low can you go?
So the part, this part, first part of my range is going to start at
Negative.
negative infinity, right? Okay. Now, and there's two pieces going down, it doesn't matter. As we follow these pieces up,
0.
how high do we go?
0.
We're going to that point there. Now, if you hit trace,
I get 0, 0.
it's going to pop you on the y-axis, and where does it happen to pop us at?
0.
0, 0. So right there, it's going to go to 0, 0. Important value in that is the y value of
0.
0. So that upside down parabola goes down to negative infinity, up to 0. Does my graph touch 0?
Yes. Yes, it does.
Yes. Because up there on my trace, I see 0, 0. It's the vertex of that parabola piece. So I'm going to use a bracket. And then we're going to union.
Union nose.
Okay. Now, you have these top two pieces, yes?
How do you get to the other ones? Can't trace up there.
It just looks like it's going to infinity, going up.
Okay.
Couldn't this technically just be negative infinity to infinity?
Is this like an asymptote?
No,
of,
because
like,
there's a
one?
break here.
Is it an asymptote of like one?
Hold on. Okay, so Logan's question is how can I get to these side pieces? Trace left or right. So if you trace far enough right,
Oh, you.
it jumps up to the top half.
I got
because
you.
when you trace, it's tracing your x values, left and right. So as I trace right, notice it hops up here, and then follow off to the right or the left, and watch your y values. If you watch my y values, 1 point, 1 point,
Asymptote of one?
Oh, yeah.
and then notice, am I ever going below 1?
Mm-mm. You can't.
Okay,
That'd be
so
one
there
infinity.
is a horizontal asymptote at 1. You can keep tracing, but you're not going to go below 1. That's my calculator clue. So there is a horizontal asymptote at 1. So my top piece is going to start the y's at 1.
Parentheses.
I'm using a parenthesis because are we going to touch 1?
No.
No. And then
Infinitely.
how high do I go?
Infinity.
Up to infinity.
And beyond.
Okay, guys. 2 through 20. It's not multiple parts, I promise. You've got like 4 functions, 3 or 4 domains, 2 or 3 range. Attempt them all. Use our techniques. We'll talk on Monday.
Where's the game on there?